name is Muhammad Adai Kabir Abdul Aziz. My student ID is 2021870344.
Assalamualaikum, my name is Muhammad Fikri Aziz bin Muhammad Shukri. My student ID is 2021207394.
Hi, my name is Muhammad Adi bin Azli. My student ID is 2021856922. We are from Group A.
Okay, our presentation is about calculus, chapter 3, application of depreciation. Okay, these are our table contents. Number 1, introduction. Number 2, problem statement. Number 3, problem solution. Number 4, conclusion. Number 5, references. Differentiation, why you use differentiation, the concept of derivative, and the last one, relative rates. What is differentiation? Number 1 is a process of finding function that output the rate of change that you're going to use in the relative rates. Number 2, differentiation calculate the slope at any point of the graph or nonlinear function. Number 3, derivative has the function dy dx that we use in solving the derivative answer. And the last one, using power rule, also known as dy dx. Okay, the concept of derivative. We ever found the slope of the line of the graph, that's the derivative. We are looking at the curve instead of linear graph. It gets difficult to find the slope at every point because the slope is constantly changing. The way to find the slope is to zoom in on the graph at any point and find the slope at that point. Okay, this is the example. Okay, between this point, we calculate using the formula y2 minus y1. Yeah, according to the coordinates, divide by x2 minus x1. Okay, it's pretty easy, right? Okay, let's continue in our presentation. We realize use of depreciation. Depreciation equation and remarkable ability to predict the world around us. They are used in the wide variety of disciplines for biology, economics, physics, chemistry, and engineering. Why use depreciation? Number 1, to calculate the profit loss and business using graph. Usually, in a lot of companies, they're using a depreciation or derivative to calculate their profit, all their loss, their income. Number 2, to check the temperature variation. Number 3, to determine the speed or distance covered, as miles per hour, kilometer and or kilometers per hour. You can calculate the speed of cars and motorcycle and so forth. Number 4, is the common derivative are used to derive many equations in physics. That's why derivation is so important. Number 5, in the study of similarities, like to find the range or magnitude of the earthquake. Okay, the last one, in the medicine, the cancer grows. We can the last one, in medicine, you can use derivative to find a cure for cancer. A medicine to cure a lot of diseases. Okay, relative rates. That's the topic we're going to talk about. Relative rates are changes or change associated with the two or more relative quantity that changes over time. Because science and engineering often relative quantity each other, the method of relative rates and broad application in this field. Relative rate problem involve finding a rate in which a quantity changes by relating that quantity to other quantity whose rate of change are known. The rate of change is usually with respect of to time. For example, the spherical ball is filled with air, both the radius and the volume of the ball increasing. Yeah, it's like the balloon. We calculate the amount of the change that is increasing or decreasing. Yeah, inflated or deflated, something like that.
Procedure in solving related rate question. The most common way to approach related rates the problem is the following. Identify the non-variable including rate of change and the rate of change that is to be found. Drawing a picture or representation of the problem can help to keep everything in order. Construct an equation relating the quantities whose rate of change are known to the quantity whose rate of change is to be found. Differentiate both sides of the equation with respect to time or other rate of change. Often the chain rule is employed at this step. Substitute the known rates of change and the known quantities into the equation. Solve for the wanted rate of change.
Example 1. So this is the diagram of this example. So the question is, a 10-meter ladder is leaning against the wall of a building, and the base of the ladder is sliding away from the building at a rate of 3 meters per second. So the question, how fast is the top of the ladder sliding down the wall when the base of the ladder is 6 meters from the wall? So the first thing we do is label the wall as W. So this is wall, and label the floor we will label as F. So from the sentence, 10-meter ladder which is from here to here is 10 meters, and for this sentence, the ladder is sliding away from the building at a rate 3 meters per second. We know that this is df over dt equals to 3. So the question, how fast is the top of the ladder? We need to find the dw over dt, which is we don't know yet, but with f equals to 6. Solution for example 1. In step 1, we take out all the information from the question, which is df over dt equals to 3, length of the ladder equals to 10, and what we need to find is dw over dt when f is 6. Using a chain rule, we create a formula to find the value for dw over dt, which is dw over dt equals to dw over df multiply with df over dt. Since we don't have a value for dw over df, in step 2, we need to find the value for dw over df. Before that, based on the diagram in example 1, we change it to 2D object. So this is the 2D object. So after that, we construct an equation that relates the quantities of intervals. Since this is triangle shape, we use theorem Pythagoras. So the equation is w power of 2 plus f power of 2 equals to 10 power of 2. And after that, the value for w is w equals to open bracket 100 minus f power of 2 close bracket power 1 over 2. After that, we need to differentiate w to f. So the value for dw over df is dw over df equals to 1 over 2 open bracket 100 minus f power of 2 close bracket minus 1 over power minus 1 over 2, and then multiply with negative 2f. So the total value for dw over df is negative f over square root 100 minus f power of 2. In step 3, now we can find the dw over dt. Since we have dw over df and df over dt, we change it to their own value. So dw over dt equals to open bracket negative f over square root 100 minus f power of 2, and then close bracket and multiply with 3. So change the f with 6. So the final value we get is negative 9 over 4 millisecond. No, sorry. The final value we get for dw over dt is negative 9/4 ms negative 1. So that's all for me. Thank you.
The conclusion is, with differentiation as mathematical technique, we have been able to reach the solution of the different methods used. Each of the methods brings a simple and clear way that can be used for practical data. Furthermore, with table and figure, we have been able to compare the actual data with the predicted data.
Okay, number 5, the last one, number 5, which is the list of our all references. Okay, that's all for our presentation. I hope you guys enjoying our slides. Thank you.
And her goal is not in her. She's a